Good morning, ladies and gentlemen. Welcome to the online conference of INNO-COMP Group, INNO-Vision of Sustainable Solutions. My name is Vanessa Hamzók and I am the host of this online conference. The main topic of our event will be the sustainability, including two main topics, recycling and biosolutions. During the presentations and even the panel discussion, you can raise questions to the speakers via the question and A part of the platform. I would like to thank each participant for joining us, and now I will hand over the floor to our first speaker, Mr. István Balog. I wish everyone a successful conference.
Good morning, ladies and gentlemen. Thank you for joining us today for this webinar hosted by INNO-COMP Group. My name is István Balog, and I have the privilege of serving as the head of the sales, project and marketing at our company. Over the next few minutes, I will be guiding you through our company's journey, highlighting our commitment to sustainability and recycling materials. Let's start with an overview of INNO-COMP Group. Our headquarters is located in Tiszaújváros, Hungary. We have two production plants, strategically in Tiszaújváros and Litvinov. These facilities serve as the backbone of our operations, allowing us to deliver high-quality products to our valued customers. In Tiszaújváros, we operate 5 compounding lines, averaging a capacity from 200 kg up to 3 tons per hour. These cutting-edge facilities enable us to meet the demands of various industries with efficiency. In Litvinov, we maintain 4 production lines with capacity ranging from 400 kg up to 4 tons per hour. These production lines are a testament to our commitment to innovation, ensuring that we can adapt to the evolving needs of our customers and the market. Now let's dive into some key statistics that illustrate our company's strengths. INNO-COMP Group has a dedicated workforce of around 160 people who works tirelessly to help our success. Our annual nominal capacity is 130,000 tons, and in the last fiscal year, we achieved a sales turnover of 100 million euros. Our products find their way into various application fields. A significant portion, around 40%, serves the household appliances sector, where our materials contribute to the innovation and durability. Another 30% goes into pipes, helping to construct efficient and robust environment. The automotive industry, a sector synonymous with precision and performance, receives 20% of our products. Lastly, 10% goes to specialty applications, for example, packaging or medical hygienic segments. INNO-COMP Group takes a pride in our comprehensive product portfolio. Within the polymer group, we offer a diverse range of materials, including homopolymer, copolymer, random copolymer, and PLA, ABS, polyethylene, and polystyrene. These materials form the foundation of our compounds, providing options to meet the customer-specific needs. Our main fillers are talc, chalk, mica, glass fiber, carbon fibers, and barium sulfates, among others. These fillers play a huge role in enhancing the performance of our compounds. The properties include a range of special characteristics that our compounds can offer, such as UV-stabilized, long-term heat-stabilized, scratch-resistant, odorless, flame retardant, lightweight, impact-modified, and conductive properties, among others. It's worth noting that our compounds are highly customizable to meet the specific requirements of our partners. Let's dive deeper into our compounds. Our material can consist of specialty features. They can be flame retarded, ensuring safety and reliability. We also offer lightweight solutions, contributing to energy efficiency. Our glass fiber reinforced compounds offer increased strength and we present low odor products as well. Furthermore, we are proud to provide biogrades and recycled solutions, underlining our commitment to sustainability. Before I conclude, I would like to leave you with a thought that embodies our philosophy here at INNO-COMP Group. Even the impossible is possible together. This emphasizes the role that our partners and consumers play in our journey. The success is combined with the trust and collaborations we share with all of you. Together, we can achieve remarkable accomplishments in the world of compounding and plastic. Now, you might be wondering why to work with us. Competency in plastics engineering and state-of-the-art laboratory. We bring extensive expertise and cutting-edge research capabilities to the table, ensuring the highest quality compounds and solutions. High mobility and flexibility. We are agile and responsive to your changing needs and market dynamics. Sustainability business approach. Sustainability is at the heart of our operations. We are dedicated to a sustainable future, both for our business and the environment, and this commitment reflects in everything we do. Finally, I would like to thank you for your attention.
Thanks to István for the company presentation. Now, I will pass the floor to our next speakers. Firstly, please welcome Mr. Jan Klima.
My name is Jan Klima, working as a Quality and Environmental Manager for INNO-COMP Bohemia and Litvinov. Compounds based partly on recycled materials show the same or very similar physical properties as new materials. Just application field has to be chosen correctly, based on some of these points of interest: durability, odor, and visual appearance. In the past years, the growth of regran was increasing. Years after, the situation became different due to lower demands and some market changes. Unfortunately, potential of regran is blocked by characteristic on the level of virgin materials, mainly by automotive industry, what usage of regran pushes down. Different options of recycling. The most common method is mechanical recycling. During the mechanical recycling, there is necessary to separate incompatible polymers. Recycling to virgin materials or energy recovery are alternative methods. The last stage for non-recyclable materials is unfortunately landfilling. Role of compounder. Compounder has close cooperation with a molder based on customer requirements and or engineering requirements. Customers get their product packaging, or the product at the end of its life goes into waste. The waste is collected, mechanical and chemical recycling is the next step. Afterwards added some fossil feedstock, and it finally goes in polymer production, and the loop is closed by compounder. Due to multiple regran types and sources, the quality of regran is not constant. The role of compounder is to filter out all deviations and provide constant quality of compounds. PP takes between 20 or 30 years to biodegrade naturally. So keeping it out of the ground is a priority. Recycling PP has two main benefits. It helps to reduce the amount of plastics going to landfill. Recycling PP takes much less energy than creating new PP products from fossil fuels. Estimates suggest that PP recycling emits 88% less CO2 than producing it from scratch. We can do more to reduce the emissions via reusable packaging, transport types, or energy sources, and so on. There are two sources of recycled material. Post-consumer waste refers to finished goods. Post-industrial waste refers to waste material generated from manufacture processes. Post-consumer plastics has been used by the customer for its intended purpose. These are regranulates produced from plastic waste from yellow bins. It means from end customers and households, which are very heterogeneous and polluted, what means sorting, mechanical or chemical recycling, and washing additionally. The quality of the post-consumer granulate also determines the look of finished product. Post-industrial plastic that never made it to the end customer. Post-industrial materials come from waste generated during any manufacturing processes. The recycling of post-industrial plastics benefits from the fact that the input waste is of a known composition and controllable, making the recycling process more efficient. More precisely, manufacturers know exactly what type of plastic is used, eliminating the need of clean and decontaminate the plastics. And that leads me to the last slide, that INNO-COMP entered in a joint venture and founded a recycling company, INNO-GAV, in 2019. So we can control our recycling material streams.
Hello, my name is Balázs Kugler, Project and Marketing Manager from INNO-COMP Hungary. In today's presentation, we would like to give you an overview of our bioresearch, to know more about the material solutions, what we can offer, and what we experience with this kind of materials. As a compounder company, we are continuously testing new polymers, new formulas, new fillers, to be well prepared for the future needs. Bioplastics includes two main topics. The first is the natural biofiber filled compounds based on fossil polymers, for example polypropylene. And the second one is the biodegradable polymers based on PLA. Firstly, Zsuzsanna, our development specialist who owns this topic at our company, will speak about the biosolutions with basic definitions and about the most popular polymers on the market.
Thank you, Balázs. I'm Zsuzsanna Havas, Product Development Specialist at INNO-COMP Hungary. I would like to give you a short technical summary about the bioplastics and biocomposites. Plastics can be placed in a coordinate system based on monomer source and biodegradation, where the horizontal axis shows the biodegradability of the plastic and the vertical axis shows the origin of the monomer. So we distinguish four groups. First is the non-biodegradable plastics made from fossil-based raw materials like polyethylene, polypropylene, PVC. Second is the non-biodegradable polymers produced from biomass. For example, polyethylene and polypropylene can also be produced from biomass-based monomers, so they are called bio-PE and bio-PP. Next is the biodegradable plastics from biomass raw materials like PLA, PBS. Last group is the biodegradable plastics from fossil-based raw materials like PCl or PBET. The last three group called bioplastics. Based on the global capacity of bioplastic production, the most significant biodegradable plastics are PLA, PBET, and starch, so we are constantly developing compounds based on these polymers. The biocomposite is a multi-phase system where at least one component comes from a natural, renewable resource. The biocomposite types are shown in the figure. For example, if the polymer matrix is a conventional plastic, like PP, then the reinforcing material comes from a renewable, natural resource. If the polymer matrix is biomass-based, the filler can be a natural, renewable source or an inorganic material. We have solutions for each category, but in this presentation we present the compounds of the first one.
And the next main topic of our presentation is the natural fillers used in traditional polymers. Let's see the benefits. Environmental fit, far superior recyclability. Compared to, for example, glass fiber, its properties weaken each recycling round. But for example, the wood fiber keeps the properties more after recycling. Less health and safety issues, not toxic of course. High natural revenue filler content. Design, marketing. You can see on the pictures the surface shows filler particles, kind of brownish wood, looks like a wood. LCA and carbon footprint, this is the life cycle analysis. Very hard to prepare the right carbon footprint calculations because of the contradictional informations in the literatures, but our colleagues are working to demonstrate the reduced carbon footprint with realistic numbers for each type. Lower density and processing cost compared to mineral field grades. I'm thinking about the abrasive effect of the filler, which is compared to hard materials like glass fiber and barium sulfate filled materials. In this case, the cost efficiency is meaning the lower weight, lower density, because the polymer prices are calculated for weight in tons. In the following table, we will illustrate the tested fillers, reinforcers, types, and their most important properties. I would like to draw attention to the availability. All the fillers are plant-based and coming from the agriculture. This is different business. Depends on the weather, plant epidemics, and on the buyers from all kinds of industries, created variable price competitions. Forecast is very important. We have to agree the quantity a year before, minimum a year before. In case of a change, we cannot wait for plant growing. You can find in the table 9 different natural fillers, price levels, available, yearly quantities, and these were tested typically on polypropylene and PLA basis. The maximum availability, which you can see as blue line in around 1,000 ton per year. We have not been authorized to show the supplier's name and prices, therefore I can share only the price levels, as you can see in the table.
As you can see, we tried a wide range of fillers in different forms, granules, fiber, flour, and in different particle sizes. We have experience in compounding and injection molding, so we can also fulfill individual requests. The physical properties can also be modified with so-called hybrid composites, which contain mineral-based fillers in addition to polymer and natural fillers. In general, it can be said that compounds containing natural fillers have a brownish tint. Some compounds with fillers can be colored well, but others less so. The following figures show some measurement results. The same copolymer polypropylene was used as the base polymer. The amount of filler was 30% in all cases. In comparison to the base polymer, which is colored blue in each diagram, we can see the change in physical properties in the case of ground apricot shell, hemp, and wood fiber. Composite results filled with talc and chalk are also presented. The MFL value of the compounds containing natural organic and mineral fillers was almost the same and decreased by a similar value compared to the base polymer. The density of the biocomposites was around 1, which is much lower compared to PP filled with 30% talc and chalk. Yield strain and strain at break the biocomposites is between that of the chalk and talc-filled compound. Yield stresses are better than base polymer and other compounds. In the case of flexural modulus, there are significant differences between the fillers. Wood fiber increases the modulus the most, better than talc. Hemp is almost the same as talc, apricot shell is the last. In the case of receipts with natural fiber filling, the sharp impact properties decrease the effect of inorganic fill and composites is better.
Few words about the injection molding of the biogrades. Drying is very important in case of moisture-sensitive material like this. Temperature, higher temperatures can cause burnout. That's why this is the maximum 200 degree, which we propose for the processing. mold system, particle size of the fillers has to be lower size, of course, than the nozzle. You can see the testing parts mainly from the household appliances industry. We successfully tested many of biomaterials for different wall thicknesses, surfaces, colors, to get more experience how the material behaves for different injection parameters. We hope we managed to convey the message. As a compounder company, we do our best to meet the customer needs, and we are open to think together with our customers. This is absolutely true for a new field like the biosolutions. It is off the beaten path. Thank you very much for your attention.
Let me thank to my colleagues, to Zsuzsa, Jan and Balázs for their presentation. As a starting point of our series of webinars, they presented the fundamentals, and now we can begin our journey together with you. We can only be successful on the path of sustainability together. Now let us imagine what our clients would need in 10 years, what they would expect from us. Of course, we can base this only on the currently existing possibilities, but we see three options. Good that it is. Certainly, this is not a solution. Here, it is existing only technically and does not offer any solution for our urgent questions. But once we are coming to recycling, we also have to make compromises, at least with the color, but I think it will be more. I can't believe that a 100% post-consumer based compound can meet the requirement of or standards which were once based on virgin polypropylene. Maybe they can do it on test parts, but already at the injected part, they may behave differently. Here we will do our best to supply you with the available data for simulation. A well-designed part might be a solution for most of our problems. Certainly, besides this, we will face the previously mentioned challenges like availability or the quality of the post-consumer waste. Here we have to manage our production population in a way that we can guarantee the right qualities for you. Certainly this will give challenges for our production also. Biocomposites. And why I said composites and not bioplastic is easy. For functional part in an equipment which has to survive for decades with its owner, I see a lot of potentials for PP-based biofilled compounds. These materials will be faster available for mass production just based on the capacities than the bioplastics. Certainly compromise will be an issue here with similar properties like with the regrants, color, maybe smell or odor, and the physical properties. We are putting our utmost effort to develop the right raw materials teams for us together with our suppliers, and we are offering sustainable solutions which long-term guarantees the success.
Thank you for my colleagues to these exciting and interesting presentations. Our conference is slowly coming to the end, but before that, my colleagues would like to answer the questions that have been asked during the event. So, this is the question and answer session of our online conference. Welcome back Zsuzsanna, Péter, István, Jan and Balázs. Let's see the first incoming question. So, the first one is, do not think you are late with these solutions. Maybe Péter?
Thank you, Vanessa. Yes, it's not an easy question because we presented now our work, but actually we do this since many, many years, developing great streams for different kind of materials. You may say we present it later, but please believe me, in many work hours and years has been invested already for these streams. Recycled materials we are offering since many years to our customers. And about bio, I would ask Balázs.
Yes, from the bio point of view, we started the first test 20 years ago with the bamboo as a filler for polypropylenes. And that was already 20 years when we started.
Yeah, so it's playing a significant part of our development activities.
Okay, thank you. The next one. What do your biggest competitors are? István?
Thanks, Vanessa. Very interesting question, I would say, because of course, without mentioning the names, I think it's clear that due to our size, our capabilities, we do not fight with big guys. It's out of options. In that case, I think we can say that we are looking more to the market followers, let's say, to the medium-sized producers. And okay, without any blah blah, I will give you the name just to be direct. I think we can openly say that somehow orientation for us is kind of Silmax like competition. And it has to mention that, of course, competition is one thing and production is one thing. We are a PP compound mine companies, actually. Even if somebody is producing technical compounds, it's kind of out of scope. So this is also a little bit orientation, but kind of Silmax style approach from us, and we do not look for big flyers and market leaders.
Okay, thank you. And I think the next question goes to Jan. So how many of your projects are based on regran?
Well, I'll try to answer. Based on our documentation, I guess we have about 50% of currently received projects based on the regran. I mean, PPH and PPC regran-based compounds with glass fiber, talc, and so. They are mainly post-industrial, but they also have post-consumer regran based projects as well.
Okay, thank you. And the next one is, do you have a product that has a certificate for a renewable raw material content?
Yes, I think it's for me because it's for the biocomposite. The biocomposite is the main question: how many renewable raw material? How much is the renewable raw material content in the compound? There are several bodies, certification bodies, where can we get a certification. One of them is the TÜV Austria. It is this certification based on measurements and calculation, and they measure the bio-based content in the compound, and they give 1, 2, 3, and 4-star bio-based certificate for the compound. We have one certificated compound. This is the so-called CSB03920SF, which is a PLA-based, polylactic acid-based compound filled with 20% ground apricot shell. The apricot shell is from Hungary, and the grinding process takes place in Hungary, in Tiszaújváros, in INNO-COMP. This is we offer for injection molding. And if you would like to get more information about this grade, please write us and we can send you the TDS.
Thank you, Zsuzsa. So the next incoming question is, what do you think about future regran prices availability? Maybe Peter?
Thank you, Vanessa. So I think this is a question where we can spend the rest of the day discussing. Of course, I mean, it's depending on many factors, considering whether we are talking about post-consumer or post-industrial regrans. Post-industrial regrans is an easier subject because they are less in CO2 calculations like the post-consumer regrind. Therefore, I would like to focus a little bit on the post-consumer regrind. Post-consumer regrind is basically depending on what we are putting into the yellow bags, or what we are taking to the landfills, I mean to the recycling plants, so for the bigger machines and for the cars, and how much of that we are able to select and separate. There are very good technologies, so I think the amount of recyclable streams from the waste are increasing, but certainly this will have an impact also on the quality, in my eyes. So we may see very different quality sources for post-consumer regress, and also the price will be set accordingly. So it's very easy to say that now a good quality post-consumer regrind from a source which is certified is well above the prime price. We are talking about €2 plus per kilogram for these materials, whereas the lower end of this market is somewhere around 720, maybe 750. Of course, the quality of that material is close to unprocessable. So, I mean, I think this will change in the future in a way that availability reduces, because everybody has to use PCR regrind in the future since 2031, if I am correct. And that will define the price levels of the materials, but I still believe that it will vary in a very big range. So we will not be talking about plus minus €50 like in the case of the virgin materials, but we will talk about hundreds of euros difference between PCR regrinds depending on their quality.
Thank you, Peter. So let's see the next one. Why do you think that PLA or biopolymer-based compound can be interesting for durable good? Balázs?
Yeah, this is a good question. Of course, for example, you can imagine that there is a part which made of PLA, for example. I put it on the table, and that will be still on the table in 20, 30, 40 years. So it can be used, of course, and on the other hand, very easy to degrade, because it's only the question for the temperature.
Okay, thank you, Balázs. Which filter do you recommend to use for injection molding application? Zsuzsa, would you like to answer it?
Yes, as you saw, we used and we tested several fillers, and using filler, it depends on the final properties of the final product. If you would like only a filler like a calcium carbonate, we can recommend wood flour or corn cup, ground corn cup, ground apricot shell. This is behave like a filler. And if you would like to get reinforcing properties like a glass fiber, then we recommend the wood fiber or hemp. And yes, the most important is that these compounds have a brownish color, can color to different colors, but the filler will show on the surface of the final material.
Thank you, Zsuzsa. So I think the next question goes to Balázs. So do you consider producing compounds based on biodegradable polymers?
Yes, we are testing biodegradable polymers to be well prepared for the future, but currently this is not a way from the market, because these kind of polymers are not ready in large quantities, so for industrial applications. Consequently, the price is really high, and the availability is also not the best. Only in small volumes are available. So proposed only for special application fields currently. We are testing, but yes, maybe
it's a material of the future.
Yes, this is for a long run.
Thank you. And the next one is, how do you control your regram sources? Maybe Jan?
Well, in my presentation, I mentioned the INNO-COMP company, what INNO-COMP is founder of. The best way is to have like a reliable partner for that. So means our regram, our scrap goes to INNO-COMP, who prepares the regram for us to reuse it, and we also get the regram from INNO-COMP from other sources as well, prepared by INNO-COMP. So that's probably the best way at this moment.
Okay, thank you. And last but not least question is, what is the most important segments of your regram development projects? István?
Thanks, Vanessa. So as you could recall my presentation, or my part of the presentation series, we don't have thousands of applications, so it's very easy to nominate one or two out of four. So that's why if you allow me to go back to the history, giving you a little bit time frame of this journey. So I think 2-3 years ago, the revaluation kind of started. Customers approached us asking for anything which is cheap. So that time the drive was just cost reduction. After that, the market and our partners, and also we realized that there is strict regulations, expectations from you, from industry standards. So people started to look, and our partners and also we started to look for solutions, which meant using PP regram and all kind of biocomposites into our recipes. And the latest development is that somehow new startups and smaller partners came out to the market and using the bio concept, the biomarketing, and actively separating themselves from the fossil-based materials, saying that we are green, we are producing green materials, and it's different than what was done in the past. But coming back to the original question, I think the front runner was automotive, no question about it. I think they are still now in the first league, so automotive partners are looking for this new kind of solution. Not now, maybe the season. Let's say the season will start in 2025 and afterwards. So according to our budget, we will be producing. Hopefully, we will be producing a few thousand tons of PP regram-based compounds by 2028, definitely. And finally, and it's also good news that recently the white goods sector is catching up. So a few projects over there, limited, I would say, not a big numbers, but volume-wise, it's very promising. So the order is automotive, following by the white goods industry. That's our view at this moment.
Thank you, István, and I would like to thank for my colleagues and the attendances. The not mentioned questions will be answered by email, which we will send to all participants. Thank you for participating in our online conference. We were delighted to have you here, and we hope you have gained valuable and inspiring insights today. Remember that the conference materials will remain accessible on our online platforms. See you next time.